Hi Lakewood, and welcome to my lesson on converting fractions to decimals, terminating or repeating. So I found this problem and I wanted us to look at it because I thought it was pretty interesting. Repeat or not? That is the question. So there's a scenario here. The 7th grade students at Euclid Middle School earned a pizza party for raising the most money for a charity. The 7th grade teachers ordered 20 pizzas. The table shows how many pizzas each class ate at the party. When I look down at the list, not only do I see some names that are a little difficult for me to pronounce, but I also see some numbers that really don't seem to fit together. I see some mixed numbers, I see some decimals, and I have a feeling this is going to be a little bit complicated and cause some problems when I start looking at the problem. So the first question is, Mr. K's class ate 3.5 pizza, and Miss Lanter's class ate 2.75 pizzas. Write an expression that you can use to calculate how much more Mr. K's class ate than Miss Lantern's class. Show all work. Okay, so we look at this and I say, I know that this is a subtraction. So I'm going to take Mr. K's class and I'm going to say, oops, sorry, didn't mean to make you seasick. 3.5 minus Ms. Lantern's class, which is Lanter's, 2.75 equals, and I get ready to do the math and I realize I've got a problem here. I know that I can't subtract when I have my numbers, one in fraction form, one in decimal form. Luckily for me, we know how to convert back and forth between fractions and decimals. I have a choice here. I can either use fractions or decimals as long as I use the same within the same problem. I'm going to go for decimals because I much prefer to subtract with decimals than I do with fractions. So I'm going to write my problem. I know that the 0.275 is not going to change. I know that the 3 is not going to change. I just have to change that 1/2. I know that 1/2 means nothing more than 1 divided by 2. So over in my workspace, I am going to show that. Now, I know you're thinking, Miss Hensley, I know what the answer is. And yes, you do. But because it says show all work, you're going to have to show the steps that you could use to get to your answer. So I'm going to say 1 divided by 2. Careful here, because we so often feel that we need to say the larger number divided by the smaller number. We're not in elementary school anymore. We need to be able to divide a smaller number by a larger number. This is 1 divided by 2, and that's what it looks like. When I convert decimals into, or fractions, into decimals, I know that the answer is going to be between 0 and 1. And so I'm going to have a decimal in my answer. So before I even start doing anything, if I'm converting a fraction to a decimal, I go ahead and I set my problem up to show that decimal that's hiding out behind the 1 and the 0, and I'm going to bring that decimal up and I'm going to forget that it's there. Now I don't have to worry about the decimal. I just see the problem as 10 divided by 2. Well, I know that 2 can go into 10 5 times. 5 times 2 is 10. I subtract, I get 0. I am finished. So exactly as you knew that 3.5 is the same thing as 3 5/10. But we showed our work. Now we have to do the second part of the problem, because it wasn't just convert, we need to actually do the subtraction. So remember that when we subtract with decimals, we want to line the decimals up. Sometimes I like to use graph paper for this. But I'm going to go ahead and write 3.5 minus 2.75. This is the time to write carefully, slowly, keeping everything nice and neat and orderly. I also see that this bothers me. I have this empty space here. I'm going to just fill that in with a 0 because I know that 3.5 is the same thing as 3 50 100ths, or $3.50. That makes my subtraction a whole lot easier. I know that I can just bring that decimal down, forget that it's there, and just do my subtracting. So let's subtract. We get 5, come over here, and we get 7, and we get 0.75. 75 hundredths, or because I know that's 3/4 of a pizza more. And that answer makes sense. Pretty simple, right? Great. Now let's try this problem. Let's see. Yeah, let's just put it here. How many pizzas did Mr. Stoller's and Miss Dietrich's class eat together? Forgot to say the class. That's okay. Just a little typo, but it's been fixed. How many pizzas did Mr. Stoller's and Miss Dietrich's class eat all together? Well, I know that this is all together. This is going to be addition. So I go to my chart and I see that Mr. Stoller ate 2 11/12 of a pizza, and Miss Dietrich's class ate 4.25. Okay. I'm going to do what I did last time. I much prefer to work with decimals, so let's go ahead and convert 2 11/12. I'm just going to do it right here. I'm going to say 11 divided by 12. I'm going to add my decimal 0, bring my decimal up, forget it. How many times does 12 go into 11? It can't. How many times can 12 go into 110? And I know this is where a lot of us just say, never mind, I'm going to guess. But I'm going to show you a quick trick. If I list my multiplication out for my 12s, and if I have a multiplication table, I can just go ahead and use that. But I know that 12 times 1 is 12. Times 2 is 24. Times 3 is 36. 48, 60, 72, 84, 96, 108, 120, and that gets me far enough. So I'm going to go back and say that's my 3 times 4, 5, 6, 7, 8. Oh, I lost something. Okay, sorry. Too many days off with the tropical storm. Let's try this again. How about we say 4, 5, 6, 7, 8, 9, and 10. We'll just mark those right on out. So I know I'm looking for 110. 110 is between 108 and 120. So 10 is going to be too much, and I can't put 10 in there anyway. So let's do 9. Now my multiplication is already done. So 9 times 12 is 108. I subtract, and I get 2 left over. No problem. I can add a 0 and bring that on down. 12 goes into 20. That one's easy. 1 time. 1 times 12 is 12. I can subtract. I get 8. Still not a problem. I can add a 0. 12 goes into 80. I go 7 times is 84. Too big. 6 is going to be 72. Now I'm going to subtract. I bring down another 0. Well, I just did that problem, so I know that that's 6, 76, 72, excuse me. When I subtract, I get 8. Okay, wait a minute. Do you see what's happening? I could sit here from now until continuation, beyond, and it's going to always repeat. This same pattern is going to repeat. I end up with the 8, I bring it down, 86, 72, 80, and it's going to go on and on and on. We have a special name for these kind of decimals that repeat a pattern like that. They're called repeating decimals. Pretty original, isn't it? So when I write that repeating decimal, I'm going to need to be able to say, well, how do I write this and show that the 6 repeats? This really isn't the right answer, because this says that I have 6 thousandths and no 10,000ths. But I really do have 10,000ths right here. So I have to show that that 6 repeats. We use a simple bar called a repeating bar, and that shows that the 6 repeats. Notice that only the 6 has the bar over it because only the 6 repeats. Great. Now I have a decimal. I have 4.25 and I'm going to add 2.916. I can't add a repeating decimal because there's not an exact number that I could use to add. This right here is where sometimes I can't convert to decimals, and it really would have made more sense for me to have to change things to fractions, and I bet that would have made things a little bit easier. Well, we can do that because I can look at 25 hundredths is one of those common decimals that you just need to know. 25 cents is a quarter. What does that look like? A quarter is another way of saying 1/4. And then you can add those two together using whichever method you prefer. So, just a couple of things that we have to do to think about and keep in mind when we are converting back and forth between fractions and decimals. So let's summarize with a few notes down here. When I am converting a fraction to a decimal, one of two things is going to happen. The decimal will either terminate or end, and I already have that there, or it will repeat. I have to keep doing the long division until one of these things happens. If a number is a fraction is always what we call a rational number. And a rational number, when it's converted into a decimal, will either terminate or repeat. So, unless it tells me, the directions tell me I can round, I have to keep going until my numbers terminate or repeat. We use the repeating bar for this. So let's look at a couple more examples. Let's do let's see if I can find a good example. Let's do 7/8. So I'm just going to come down here and I'm going to do some work in the work zone. And I'm going to say, let's see what we get when I turn 7/8 into a decimal. I'm going to say 7 divided by 8. And I'm going to add my decimal 0, bring the decimal up, forget it. 8 goes into 70. See, 8 times 8 is 64. 8 times 9 is 72. So it's going to be 8, 64. I'm going to subtract. I get 6. It hasn't terminated. It hasn't repeated. I'm going to add a 0. Bring that 0 down. 8 goes into 60. The 8's too much. Let's go 7. 56. I'm going to subtract. Still going. Add a 0. Bring it down. 8 goes into 40. 5 times. Finally, if I get 0, then my answer terminates. So the fraction, since it terminates, the fraction 7/8, which is equal to 0.875, is a terminating decimal. What are we going to do with something like 1/7? Let's try 1/7. 1/7 is 1 divided by 7. Add my decimal 0. Bring the decimal up. Forget it. 7 goes into 1. 1 time. And I'm just going to start subtracting. You can subtract at your own speed. Another 0. Draw that line out. Oh my gosh. What is going on here? But it hasn't repeated, it hasn't terminated. I have to keep on going. Just keep on adding those zeros. 35, that should be 5. 35, I'm going to have to curl around a little bit here. 50, 49. I'm gonna, 7 goes into 10. I keep going. And let's see, 1, 7, 3. Looky here. Now, I really should go through the whole pattern and let you see that it does in fact repeat. But here is my answer. Here is my repeating decimal. 1/7 is equal to 0.1428571. And that whole thing repeats over and over again. Some are a lot easier. We know things like 1/3. We've done this one enough that we know that that is 0.3 repeating. Where does that come from? 1 divided by 3. And it goes in 3. And this one is so quick to see that it's going to always follow this pattern. So we put the fraction bar over the 3. And that's it. Other than really taking your time and not giving up if the long division takes longer than you think it should, it's really pretty simple. So what I would like for you to do is to do a little practice. Here are 6 problems. Please, the directions say convert to a decimal. Tell if it is a terminating or repeating decimal. And you can just copy this on your paper. And if you will pause the video, complete these problems, and then you can restart the video to check your answers. See you in a minute. Okay, here are the answers. Just a couple of things that I want to point out from the answers. The first thing is to be careful where the repeating bar goes. If I were to put 13, and when I did long division, I know that I see that it's only the 6 that repeats. So only the 6 gets the repeating bar. When I did 7 divided by 22, the 3 didn't repeat, but the pattern started with the 1, 8, 1, 8, 1, 8, 1, 8, and I used my repeating bar over that. Negative? No problem. Same rules. Remember that this has a negative divided by a positive. Negative divided by a positive is negative, so my answer is negative with my repeating bar. And we can check those other answers. One other thing that I want to just kind of warn you about, that when you start using repeating decimals and fractions with your calculator, there are a couple things that you need to be careful with. We're not using that quite yet, but I want to show you. So I'm just going to use my phone because I don't have my graphing calculator handy. But if I say 13 divided by 15, I see this 0.866666, and I say, well, it ends, and that ends in a 7. Be careful. That 7, sorry, the text came in. This 7, where does it come from? It's just where the calculator rounded in order to, they call it truncating. They have to stop it somewhere. That 6 really repeats forever. But if they have to round it, so they round it up to 7 at the end. If I say 1 divided by 3, it's not going to happen because the 3 doesn't round up. Just want to keep that in mind as you're doing things on calculators. So, I hope this helps. Please consult your work plan for the shelf work and follow-up work to go with these lessons and this lesson. And as always, if you have questions, please see your teacher to arrange a lesson. Thanks so much. Bye-bye.